Today's problem is merge sort for linked list, difficulty medium, accuracy. About 75% is really high. A merge sort is conceptually it's not very difficult, and it's recursive, and so it's an algorithm that's not that hard to keep in your head. Anyway, the problem is, given the head of a linked list, you have to sort the given linked list using merge sort. That's it. Well, all right. Here's an example. You get a linked list. It's not sorted, but after your merge sort runs, it is expected to be sorted. Is there more examples? Yeah, I mean, same thing with the other examples. Number of nodes is between 1 and 10 to the 5th, 100,000. The data, it is non-negative numbers up to 1,000,000. Okay. Expected complexities n log n. Yeah, n log n. Merge sort is n log n. Auxiliary space, we need a new list. So auxiliary space will be O of n. Company tags, quite a few. Most of which I've heard of. Topic tags, merge sort. Okay. Well, just to review, I mean, the way merge sort works is you've got, in this case, a linked list. You want to sort it, so you split it in half, and you recursively merge sort the halves. And when the sorting process is done, then you merge the sorted lists. Now, what happens is you split the list in half, and then probably you split the halves in half. Eventually you get down to where you just have one element, and then you start merging things back together. Now the merging of sorted lists, I think everybody knows how to do that. You just take the lowest, well, I mean, you've got two lists. So you look at the head of each list, and you take the smaller of the two elements, and then you can do the merge recursively also. We'll look at that, but we've got a couple helper functions here. Let's just kind of go over this. Okay, so this, we're guaranteed that there will be at least one node in the list, and if there is just one node, then it's already sorted. So we'll just return it. Now, we've got a helper method to get the middle of the list, and the way the helper function works is we've got a fast pointer, we've got a slow pointer. Fast pointer moves 2 nodes per iteration. Slow pointer moves 1 node per iteration. Fast pointer moves twice as fast as the slow pointer. So when the fast pointer gets to the end of the list, the slow pointer is just in the middle of the list. So that is our middle element. We then disconnect the two lists. All right, so we get the middle, we get the node after the middle, And then we set middle.next to null, which disconnects the first half of the list from the rest of the list. So now we have two lists. We have one list rooted at head, and we have one list rooted at next of middle, and we recursively merge sort those. Okay. Once the sort is done, we get into the sorted merge process. Let's look at that. Result. Okay, so that's the start. That is the start of the merged list. We have base cases here. Again, this is a recursive. This is a recursive method. Our base cases are if we get a null node. If A is null, then we're done with list A, and we just return the rest of list B. Similarly, if B is null, we're done with list B, and we just return the rest of list A. All right. To do the merge, we look at the data. Is the data for the A node less than data for the B node? And if it is, then we set result to A, and we proceed with a recursive call to sorted merge using the A list minus the head node, which we just removed, and the B list. If the B list, if the B node data is less than the A node data, then we set result to B, and we do a recursive call to sorted merge using the A list and the B list minus the head node, which we just assigned to the result. And when we get through the entire process, we can return the results. So that is a linked list merge sort. Let's do a quick sanity check on that. All right, that looks fine. Let's try and submit it. All right. I don't have anything else to add to that. I mean, this is something that you should know how to do with linked lists, with arrays, a merge sort. It's just splitting the data in half and then recursively sorting each half. Now that results in a series of recursive calls, probably. After which there is a merge process, also a recursive process, in which you have two lists to merge, and you just take, for every recursive call, you take the smaller of the two values at the head of the linked lists, and then do a recursive call minus that node. So that's it. Merge sort. Please like the video and subscribe to the channel. It's free, and we'll see you next time.